We acknowledge in Milwaukee that we are on traditional Potawatomi, Ho-Chunk, and Menominee homeland along the southwest shores of Michigamme, North America's largest system of freshwater lakes, where the Milwaukee, Menominee, and Knickknick rivers meet, and the people of Wisconsin's sovereign Anishinaabe, Ho-Chunk, Menominee, Oneida, and Mohican nations remain present. So welcome to our Innovative Cities lecture today. We welcome you to post comments and questions in the chat during the presentation. I will monitor those while Tom is presenting. We're pleased to have Tom Mortensen joining us today. He's a landscape architect and site planner with raSmith. He focuses on space planning, or I should say public space design, restoration, and green infrastructure. So today, as you can see on the screen, he's going to discuss how nature ignores design that is ignoring nature. So welcome, Tom, and we look forward to your presentation.
Thanks, Carolyn. Thanks everyone for signing up for this session. This content is based on a class that I've taught since 2011 at UW-M in the School of Continuing Education, and I've also given this presentation at several conferences. One was down in New Orleans, and the Greater New Orleans Foundation asked me to come down and speak about what some of the creative things that we're doing with stormwater and rainfall integration in Milwaukee, because obviously, you know, we call ourselves the freshwater capital of the world, but if you go down to New Orleans, they should be called the stormwater capital of the world because they got some major problems. And what was really interesting about that, and what I learned, is that a lot of the problems that they were bringing up, we have here. You know, the only difference is that it freezes up here and it doesn't freeze down there. But we have clay soils, we have mosquitoes, you know, all of these things that were being brought up as we were presenting the content were things that we've had to deal with up here in the upper Midwest. So what I also do with this presentation is I constantly evolve it. Everywhere I go, I'll take photos and look at examples and ideas and patterns and try to integrate this into the content just to keep it as current as I possibly can. And also, you know, again, I'm constantly learning about site planning and green infrastructure. You know, we don't have it all figured out yet. We still have a long way to go. And I think it's getting better. And the more and more conversations we have about it, the more and more design examples that we see that are actually functional and performing well and are maintained, which is a big part of what I'll talk about today, the closer we're going to get to these goals of rainwater capture and mitigating stormwater issues and flooding and that type of thing. So I'll get started here. It's not advancing like it was before. All right. I'm just going to start out with a few observations. Many years ago, you know, when the green movement was really getting pretty robust, and I guess I would say that was sort of pre-recession or during the recession, everyone was talking about going green. And I've been in the green industry since 1978 when I started this long career that I didn't anticipate of being a landscape architect. But I really wanted to shift the thinking because, you know, green is good and, you know, we all kind of use that term loosely, but what I like to focus on is water. And I think water is something that we need to get closer to, a better relationship with. We have to establish, you know, Aldo Leopold called it the land ethic. I think we have to establish a water ethic. There's a lot of things that have happened recently and then in our past that have really compromised our water. And so in design, when we're working on projects or when you're interacting with a design team or, you know, a planning study or something, water, I think, needs to be a big part of that conversation. So I just came up with this slide as just sort of an example of how to, you know, change the focus a little bit onto water. History repeats, you know, these are Mad magazine covers dating back to '71, but when it comes to our environment and energy and fossil fuels and inflation and, you know, everything that goes along with that, we've been talking about this for a long time. And that's why, you know, I put this slide together because it's still evolving and it's still changing and we need to adapt and we need to understand, Back in 1977, we were not talking about climate change. We were talking about ozone depletion and other things. So the conversation keeps going, the content changes, the discussion evolves, but it's just an interesting, when you look back at history, how it does really repeat, and it's obviously improving as we keep the conversation going. The word sustainable is used a lot, and I think sustainable is a tribal term. I mean, it means a lot of different things to a lot of different people. I personally feel, this is just my opinion, that nothing that humans do can be truly, fully 100% sustainable. I think what we can do is be less non-sustainable, and we can do things that have lessen impacts and are more logically efficient. But when you really think about the word sustainable or sustainability, we have to really question, is that truly what we can achieve, or is it being more resilient, or is it just, again, using our methods, means methods, design methods, technology to become less non-sustainable? And I say that not to be a cynic. I'm just more of a realist, and I think as a realist, you have to question things. You have to challenge things. You have to really get to the crux of what these words and these phrases and these means and methods actually mean. So some other observations, people went to college to learn how to do this. And I say this in a joking way to all my colleagues and friends who are civil engineers, who I've learned in my career, I've learned so much from, and I have a high level of respect for civil engineers and what they do. I just look at this though, and I think we have really gotten as far away from nature as we possibly could, and using rock and treating a resource like rainfall as a waste product, and putting it somewhere and treating it like this. I think, we've all seen much better examples of this, but these were designed projects that were designed and permitted by the DNR and by, other agencies. And this is a really cheap and easy way to think about stormwater, but this is the result too. And I think we can do much better than this. This is what I call stormwater jail. And if we continue to think of it as something that needs to go away, and I'll say later, there is no away because it's non-compressible. It doesn't go away. It goes somewhere. So I think, again, this just is on a higher level. We have to kind of rethink what we think about as water as a resource rather than a waste product. And stone is commonly used because of velocity and erosion and things like that, and it's a fine material, but sometimes it gets a little heavy-handed, and sometimes we just default to, let's just put in more stone. And this is aesthetically and I guess environmentally what we end up with. It's a pretty stark landscape. And again, I'll show you some examples of how we can do this better and not necessarily change the dynamic or the effectiveness of these stormwater systems. Lake Michigan and the Great Lakes are rising, and we're hearing a lot more about shoreline erosion. I'm reading about it almost weekly. It is something that's happening, and sometimes rock is our best friend, and it's really the only way or the only thing that we can do to try to combat the amount of erosion that's taking place as a result of the Great Lakes, increasing in elevation. So again, I'm not being a cynic. I'm not saying it's a bad thing. It's just sometimes there's a more natural and methodical way to do this, because if we take our cues from nature and really observe nature, we can maybe think of things a little bit differently and less drastically and less harsh than what we've been doing. The term stormwater management is obviously something that has been part of the discussion for a very long time. And sometimes I really question if we actually manage it. I mean, we do have ponds and basins and pipes and other things that we do. And are we really managing it, or are we just sort of delaying an effect with highly engineered systems? And so, I don't think of every rainfall as a storm. It's a pretty harsh term, stormwater management. And then you say rainfall integration, and it just has kind of a different meaning when you're designing something. Stormwater management is technical. It's permittable. It's a requirement. We must do this. These are mandated protocols. And I'm fine with that. But if you start to think of it from a design standpoint of rainfall integration, it changes your mindset and it makes you think differently about this resource that falls from the sky and what we do with it. A couple of interesting tidbits here. We use more water in a day than we use oil in a year. And that's pretty alarming when you think about that sheer comparison of volume, and that it takes 105,000 gallons of water to make one car. I think that's actually increasing with the electric cars. If you've ever looked at how much water it takes to make a pound of lithium, you better be sitting down when you read that, because it's a lot of water that it takes, and it can't be salt water. It's got to be potable or clean water, fresh water, to make a pound of lithium. So, 105,000 gallons now to make a regular car. How many thousands of gallons more is it going to take to make, lithium battery car? And we just need to be aware of that, because we're using this resource that is not infinite to do things that might have an unintended consequence down the road, and nothing lasts forever. So we keep trying to fix water, and that, I think, has become a challenge for us, because we've proven in California and other areas of the world that you can't just constantly fix it and have it when you want it at all times. And I've come up with this, we don't expect water, we expect water, we don't respect water. And I think, again, that has to change in our thinking. We need to change our water ethic. So I always ask this question in the class that I teach. And I did some research on the internet, so I know it must be true. But how many bottles of water in volume does it take to make one bottle of water? And a lot of people throw out numbers like 20 or 10 or 15, or I found some information from someone who worked in the bottled water industry, and when they calculated all of the water it takes to make the labels, the packaging, the printing, the caps, everything that it takes to make one bottle of water, including the water that's in the bottle, it's approximately 88 bottles of water to make one bottle of water. And I'm not against bottled water. I think, certain parts of our state, they need bottled water to drink because their groundwater has been so contaminated by various sources. So I'm not against it. It's just something to be aware of, how we use the water that we have. This I thought was really interesting, that Florida receives an average of 54 inches of rainfall per year, Wisconsin about 37, and yet they're required to use recycled water for landscape irrigation. And Wisconsin doesn't. And I think it's just because here in the Great Lakes region, we've been spoiled. We've always had as much water as we need, usually, at our fingertips, and we don't think of it. We don't have that relationship with it that they do in Florida. So, just a comparison here of what's happening in other parts of the U.S. even. And I was just in Seattle a couple of months ago, and this was in the airport. So they have an average of 152 rainy days per year, but their average rainfall is very similar to what it is in Wisconsin. But yet they're in their public spaces, institutions, airports, they're harvesting rainwater to use for flushing toilets. And I think you're going to see more and more and more of this. We're going to have to make these decisions. We're going to have to implement these strategies if we want to really consider long-term consequences of using fresh, potable drinking water for uses that we don't really need to use fresh, potable drinking water for. In Civil Engineering Magazine, this was a few years ago, the challenge was huge droughts in California, and now they're back. They had a couple years of reprieve for snowfall in the mountains, but we're right back to where we were. Major problems, in California and the Southwest. So their answer was new, larger, multi-million-dollar infrastructure. Again, engineering our way out of it, engineering it to fix it. And I understand why we do that. I mean, I'm not against it, but we're not really thinking about other ways or other means of how we relate to water use, and how water in certain regions is not as plentiful. So let's not make it as plentiful as possible, because all we're doing is creating an artificial ceiling of how much water we can use. So again, the answer is always let's just engineer our way out of it, and that has been proven that is not always the answer. We have a lot of problems here in Wisconsin as well. And years ago we had a sustained drought in the Central Sands region. A lot of the lakes were way down. And a big part of this was pumping groundwater in the Central Sands, because obviously if you're growing crops in sand, you need a lot of water. And so the high capacity wells that expanded in this region of the state really brought our groundwater down to an alarming low point. And this is just another kind of visual indicator of how our relationship with water should really change. We do have a lot of issues in Wisconsin with not only our groundwater, but our surface water. Part of that is tied to stormwater and green infrastructure. And as part of it is just intensive farming and some of the impacts that concentrated animal feeding operations have had on our landscape. And again, you could pull up probably at least 1 or 2 articles a week just in our own state and in our own region on what's happening with our water. And I always say to people, you can survive without a gallon of milk, but you need water. And so we really, again, need to think about how we're using this resource and what we're using it for. And the latest big issue in Marinette, La Crosse, Madison, other parts of the state are the PFAS, the forever chemicals that they're now finding in groundwater. They're also finding it in wildlife. So these forever chemicals do not break down. They were used to create firefighting foam and other materials, a lot of other materials. And these forever chemicals do not break down, and they're finding them in bald eagles, white-tailed deer, that type of thing. So I think we need to be alarmed. I think we need to be aware and concerned about, again, our relationship with what fresh water we have left. And now there are 240 new waters labeled as impaired by the DNR. This is a couple years old, so who knows where that number lies now. I just want to kind of show you here, the growth in high capacity wells from 1900 to 2016. That's pretty alarming. Now, a lot of that is because of municipal wells. It's not all agribusiness, but a lot of it is for industrial farming. And I call it agribusiness, not agriculture, because the culture is gone, in my opinion, in agriculture for the most part, and it's become industrialized agribusiness, and that is having a huge impact on our groundwater and our surface waters, especially in the central sands region of the state. So back in the 90s, we had about 50 concentrated animal feeding operations in Wisconsin. Now we have almost 300, and that definitely has an impact on our water. And you've probably been reading about, or if you haven't, maybe heard about some of the issues that they had in Toledo about 10 years ago. They couldn't drink their water. The intake pipes were sucking up this toxic green algae. Same thing is happening in Green Bay. A lot of this, not all of it, but a lot of it has to do with agribusiness runoff and the amount of waste that's being produced by these industrial facilities and how they treat that wastewater and the manure and all of the other things that happen on these large industrial farms. And it's really having a major impact on our Great Lakes, as well as some of our inland lakes and rivers. And I'll go through this really quick, but I took this picture in June of 2016 at Pete and Well Flowage, and I did not photo enhance this photo. That is actually the color of the water. And what they've been doing up there is blowing raw liquefied manure through irrigation pipes to fertilize their crops in the sand, and it ends up in our lakes. And that is a big issue because by July, this stuff is as thick as pea soup and you cannot swim in it. And this is happening. And when I tell this to people, they're like, no way, no, this can't be happening. And I welcome you to just take a look at it, and you'll find a lot of information about what's happening. So why green infrastructure? And my answer to that is because we can't keep doing what we've been doing. We have to change how we handle water, what we do with water, how we treat water, how water treats us, and how we interact with it. I won't go through this list. I'm not a big fan of having a lot of words on a screen and just reading them. You can read them for yourselves, and I'd be happy to share this presentation with anyone, afterwards. But there's a couple things I want you to think about in the middle of this group here. Water privatization is happening. It's not a public utility in all places. They are privatizing it, and it's going to go global. There is something called water hunters, and these are groups of or agencies, or not agencies, but corporations, if you will, that are looking for water, clean water, and the Great Lakes are a big target. I listened to one professor up in UW-Stevens Point who predicted, and of course, who can tell what the future will bring, but he said that within 50 years, we could be having wars over the water in the Great Lakes. And that's pretty alarming if we don't start changing our water ethic now, because the Great Lakes Compact is going to be challenged from here on in, and we have to really understand what's happening there. So historic natural patterns of hydrology and landscape, this is what used to happen on the landscape. I don't have to go through the water cycle with you, but the difference is that there was just a lot more vegetation and topsoil and infiltration that was recharging our groundwater, recharging our wetlands, and it all happened hydraulically below the surface. It wasn't about runoff, it wasn't about sheet flow, it was about a natural process, a sponge that would then replenish our river streams and wetlands and ponds. And what's interesting about that is when you really, start to look at what happens, there can be a 2-foot difference in elevation on 160 acres in, I'll just say Anago, Wisconsin. And in the lower areas, you have tag alder and basswood, and then the elevation just rises 2 feet over 160 acres, and now you have oak and hardwoods and maple. And that's because this vegetation is adapting to where it wants to grow. And I think tying that back to green infrastructure and design and site design, we really have to start thinking about these sites and these places and these parks and whatever project you're working on, and think of it like these little microclimates, and think about it like these little miniature ecosystems, and what does that mean in terms of selecting vegetation that's going to appropriately grow there or want to grow there without a lot of arm wrestling and unnecessary management in order to force it to grow where it doesn't want to grow. So again, looking at nature, you can really pick up some of these cues and just see it happening right in front of you. And then when you can take that into the design realm, it really helps determine, a better solution is my opinion. So then the impacted man-made, designed and manipulated patterns of hydrology and landscape, we came along, we strip off all the topsoil, we compact the subsoil, we sheet flow everything, we cut off that infiltration, we come back with a paintbrush, we put an inch of topsoil on top of the subdivision or the site or the whatever, and then, and then we say, hey, we're done. And what we've done is completely interrupt the natural process of how rainfall used to integrate with the earth and with the site. Now I realize you can't do this on every site. I realize you can't do this on an urban site sometimes because they're contaminated. I'm just saying it's a way that we've been trained to do it. Strip the topsoil, compact the subgrade, regrade the site, come back with a paintbrush, compact all the oxygen out of it, take out all the nutrients, and then expect things to perform well. And again, we really need to rethink what that means in terms of design and site design. So this is where I always said, there is no way. We get it to concentrate it, we collect it, we convey it, and then we make it go away. But there really is no way. It has to go somewhere, and we have to be conscious about what that means. And so here's a perfect example of that I think we can all relate to, being in the Milwaukee area. When I was a kid, they came and they channelized all of the tributaries in the Milwaukee Menominee River, and it was very, very efficient. So they thought, and it was very, very, very expensive. And there was obviously a lot of unintended consequences. Well, it's obvious to us now. I mean, I guess at the time it wasn't obvious, but what they created was a velocity in these tributaries that was so unmanageable. All it did is create more and more and more flooding, had a lot of negative consequences downstream. It was impossible to mitigate. And so after 30, 40 years, we said, well, we really have a problem. And so now there is a project, throughout the community. You've seen this at Jacobus Park, and they've done this along Lincoln Creek, and it's excellent. I mean, it's just wonderful to see that they're de-channelizing these and trying to bring them back to, maybe they can't bring them back to what they normally were with floodplains and alluvial areas, but at least they're trying to create more of a natural environment and letting nature do what it intended to do. So they call this project stream management. I call it mismanaged stream unmanagement, because it was mismanaged, and now we're going to unmanage it. We're not going to try to control it. We're not going to try to engineer it. We're going to use principles and methods that we take from nature, we create more storage capacity, we create more floodplains, we create more areas in landscape for that water to go and slow down and do what it naturally used to do. Now, again, we can't bring it back to pre-settlement situations, but I think it's just something to think about that, again, we called it stream management because we have this thing that humans can control everything. So we're going to manage the stream, and we're not. We have to unmanage the stream because we've mismanaged it. So some of the contemporary integrated patterns of hydrology and landscape, and we're there. I mean, we're using a lot of these principles as a design community, architects, engineers, landscape architects, planners. We're really starting to implement some of these strategies to just try to slow down water before it gets into the storm sewer, treat it differently, have a different relationship with it, let it infiltrate on the site when the soils are appropriate. And I always say this too, that, the photo on the bottom right is at Pabst Farms. Well, out at Pabst Farms, the soils are all alluvial. It's all glacial till. It's sand and gravel. So water infiltrates on that site really, really well. Well, you can't do that in Mequon because Mequon is all solid, heavy blue clay. So you can't apply a technical standard for infiltration or stormwater management and have it the same thing in Oconomowoc that you can in Mequon. So again, it has to be very site specific, and you have to kind of look at the landscape and what it was at one time, and then just work within those design parameters and those principles in order to have a successful way of managing that water. So I always infiltrate water where practical, and it's not always practical to do it everywhere. So sometimes we don't infiltrate. And I'll talk about that in a little while. But I'm a huge fan of permeable pavers in this climate. I know there's other regions where they use the permeable asphalt and the permeable concrete. I'm not a big fan of that. I've seen it used here. It's marginal at best, I think, unless it's maintained a lot. And I think that because of our freeze-thaw cycles, the permeable pavers have really proven themselves to be a very good and effective way to manage stormwater. And now there's a technical standard that the DNR has come up with for water quality. So there's a little bit more of an incentive to use permeable pavers that you can use to manage stormwater, so you can maybe capture back some real estate where you don't have to put it into a pond, but you can put it under the paving. And then also, just making sure that there's enough real estate to implement these systems is a really important thing that I'll talk about later. So here's an example of why I'm not a big fan. I'm not against permeable concrete or asphalt. I just think in this climate, it's challenging at best. So we did a project on the north end of downtown where we had designed the system to be permeable pavers, and the owner and the contractor opted to go with permeable concrete instead. And so they put it in, and it was performing. And after 2 years, it turned into popcorn and cracked apart, and they ripped it all out and put in the permeable pavers. Because like I say about the pavers, they're pre-cracked. So when you have permeable concrete or permeable asphalt for that matter, what do you do when it cracks? And it will crack. Do you seal it? Do you rip it out and start over? That doesn't seem like a really viable option. And it's mainly because of freeze thaw activity that happens in this climate. So I like the pavers. They move with freeze thaw. Installed properly, they're very, very durable. You can plow them. Yes, you can snow plow them. That's always the big question. But I'm a big fan of the pavers, and they do provide water quality. I'm also a fan of blue roofs. If you were to take a place like Quad Graphics or some other manufacturing plant that uses water, that has a lot of facilities, if you were just to take that roof water and use that for non-potable uses, it's amazing how much water we could save that isn't being treated for drinking water and that we're paying for, but it's actually just become part of this other system, like I was showing you before at the airport, where they can use it for other processes. And I'm a big fan of blue roofs, as long as the structural capabilities of that building can withstand, holding up to 2 or 3 inches of rainfall. And there's some really high technical systems that they're developing now with baffles and with scuppers so that they can manage the amount of water that's up on that roof depending on the amount of rainfall, because as you know, we've been getting some pretty big deluges of, how many inches in 1 hour. That is pretty hard to mitigate. So, we have to think about that there's only a certain amount of capacity, whether it's a green roof or a blue roof, that can be held up on these rooftops. There's also some newly integrated systems, and I call it new, but it's been happening for a while, are these underground chamber systems, and they're using this a lot in urban environments. They did this in Wauwatosa, they did it in front of Camp Randall Stadium, and the entire city of St. Paul, Minnesota now implements this strategy whenever they're installing street trees. And it's really it's a system that suspends or holds up the concrete plazas above, but creates an environment where trees might actually want to live. And by that, I mean, it's non-compacted soils. It's being supported by these systems, or these trays, if you will, pedestals. And the city of St. Paul has done a study on this a long time, and they save money in the long run by not having to replace trees, and their urban environments are much more resilient. So they've made the investment up front to not only have healthier trees in the urban environment, but also to mitigate stormwater, because water that sheet flows off of these plazas or off of the street goes into a system, an underground system here, that slows down and infiltrates if the soils are appropriate for it. If it doesn't infiltrate, at least it's detaining that water and slowly releasing it into the storm sewer of that which is not being used by the trees. So again, this is just a different way of thinking. We're seeing a lot more of this, and I think you're going to see more and more of this as time goes on, especially in the urban environment. Yeah.
There's a quick question about the blue roofs versus the green. Is blue better than green? I mean, I'm sure there's pros and cons to both.
Yeah, there are pros and cons, and that's a good question. It depends on what kind of green roof. I've worked on green roofs like the Madison Children's Museum rooftop, where we had a soil capacity and a soil depth of up to 18 to 24 inches to work with. Now that I can work with, but when you just can put in these 4-inch deep sedum trays and you don't maintain it, over several years, if you've ever seen a green roof after 8 years that hasn't been maintained, it's pretty much dead because of the freeze thaw. Now it's still acting as a sponge, and it's still performing some sort of a stormwater detention aspect to it. But, I'm not a huge fan of those tray green roofs. I've used them, and I understand that they have a place and a purpose. But if you're going to do a green roof and you can really make it a people place and use it for placemaking and do something with the terrain and the soil depths, I think it's a lot more effective. Where I think the blue roof is kind of a simple approach to holding back stormwater, and it's a lot less, I would call it, maintenance than a green roof. So it's sort of like pick your poison, and a lot of that has to do with the facilities management, who is taking care of the facility, who's managing all of those aspects. If you have the staff and the capacity to do it, that's great. If you don't, then that's probably not going to be your best choice.
As you keep moving forward, I'll just ask a couple more questions and then let you keep going. The question always comes up: if you're not required to do this, how do you convince developers? I think you're touching on the fact that there's an environmental benefit, but there's probably also a financial benefit if you're not paying credits. And then just talking about diversity of plants, because I would agree with the comment that you often see the same plants used over and over and over. So are there only so many choices? So 2 questions.
Yeah, as far as the plants go, there are some that are more resilient depending on whether it's an urban or not urban environment, and again, what the soils are, and that's just where years of training and knowledge and understanding, kind of play into it. There's no easy button on a list of plants that you can use for these systems that's going to work in every situation. So it's a lot more complex than that. And I'm sorry, I forgot the first question, Carolyn.
Like when a community doesn't require it, or you've already met the guidelines, how do you convince developers and landowners to do the green infrastructure?
That was always the biggest challenge when this was first being talked about. Like, what's my economic incentive for doing this? And I think MMSD has done and proven that there can be a win-win here with their GIPP grant funding program. There's also other grant funding opportunities to mitigate and manage stormwater and treat it differently than we have been treating it. So some developers have seen that as an incentive to implement these strategies. The other thing I'll bring up about the permeable pavers again is if you can store a lot of stormwater or rainfall below those systems, maybe your ponds and basins aren't as big. Or if it's a site that doesn't require stormwater management because you're not developing that big of a site, but you want to go the extra mile, there are other strategies that you can use that that can work. And I'm working on a project with a manufacturing company out of Montreal right now, and they didn't have to do anything like this, but they opted to go with a native landscape because it met their corporate sort of green sustainability goals, that they didn't want to be mowing turf and fertilizing turf and using herbicides on turf and all the resources and the watering it takes to grow turf. They opted to go with a more natural system. And the key to success there, as I'll show you in a minute, it does require money and it does require management, but long term it can save them a lot of money. And I'll mention, I'm glad that you brought that up, Carolyn, because I'll mention this as well. I think these systems, permeable pavers and things, they're very expensive going in, right? Versus asphalt. Asphalt's cheap, but the life cycle of asphalt is what, 10, 12 years, and you got to start doing mill and overlay, you got to start filling cracks, you got to restripe it, you got to reseal it with some ungodly petroleum products just to make it look black again and keep the water out of it, which I understand, but that's high cost. If you're an institution like a library or a municipal building or someone who is going to hold on to that real estate for a long time, it makes a lot of sense to consider the permeable pavers, because long term they're going to cost a lot less than asphalt and concrete, which will crack and then will need maintenance. So I think it's a decision that has to be made by the owner or by the facilities management people. Johnson Controls is one example on Green Bay Avenue where they felt that this was really important to them. So their entire parking lot is permeable pavers, and they've seen the benefits of that in a number of ways. And so, yeah, there does need to be a financial or economic reason to do it. It's not just about feeling good about what you're doing, but I think we're getting there, Carolyn, especially because the DNR has created a technical standard for water quality, and that has become a big push for these systems. So some of the design approach and techniques that I use when I'm thinking about designing green infrastructure, and I was just up north last week and I was observing how the tamarack and the aspen trees are in full color right now. The maples and the hardwood, the maples are done, but now the oaks are starting to come into their color. And so when you're in the driftless area of the state, you really start to see these natural patterns of landscape. And what it is it's big and bold. It's not complicated and vague. When you look at the Wisconsin landscape, there's just large swaths of vegetation that overlap and integrate, but it's not busy. It's not a little bit of this and a little bit of that and a little bit of this and a little bit of that. Again, it goes back to those principles I was talking about before, where nature and plants decide to or want to grow where they're going to be able to thrive and grow. And so if you think about it as big and bold rather than complicated and vague, and you implement that on a design for a site, it will really get you different results. And I also think that when you plant big and bold like this, it's a lot less maintenance because it's not complicated and vague, and it's an obvious type of approach to landscape. So I want to show you this picture because later on I'm gonna ask you to remember this, but this is the Mecan River in the Central Sands region of Wisconsin. And what you see here is you see in terms of how we relate a natural system to green infrastructure is a low flow channel. The low flow channel of the river, I'm sure that inundates and it fills up into this alluvial kind of floodplain here. So at times this will be a flashy river and fill up more after rain events, but then it's got the capacity to take that on. And then what you start to see are the side slopes. And what's on the side slopes? Trees, woody vegetation. there are no trees and woody vegetation down here in this floodplain in this low flow channel. So I want you to remember this picture when I show you a photograph later about green infrastructure. I always challenge the knee-jerk approach in terms of a design approach and technique. Don't try to force green infrastructure where it's not going to grow. You need real estate, you need space, you need soil, and you need landscape. And so, you know, your parking lot islands, if they're more generous in size, you can do a lot more with green infrastructure in those parking lot islands than you can in a tiny little sliver. And the picture on the right is Cabela's up in Richfield. This is a stormwater pond, but we designed it to look natural. And you can do that. You know, if you have a client or an owner that's willing to invest the time and energy and money to do something like this, it's a lot better than those photos I showed you in the beginning of the presentation that were just surrounded by rock and they're just a bunch of rectangles in stormwater jail. This does not look like stormwater jail, but it's a functioning pond that is managing rainfall. The Chippewa Nature Center is a project I worked on in Midland, Michigan. And as a design team, we were struggling with what do we do with the roof water? How do we integrate that in the site? How do we make it a feature? How do we teach children about rainwater? And I don't expect you to read this, but this is just a graphic that I came up with that I shared with the design team so that we could all kind of get on the same page about how we want this system to work. You know, and the water comes off the roof and it goes through this system and then it goes into this and it happens to here. And then, you know, our last line of defense is into the bio infiltration basin. But, you know, as we were talking, everyone is sort of having a really tough time visualizing it. And then as the design evolved, this is kind of what we came up for our entry sequence. And this is all stormwater related. And it really, you know, took this roof water that normally would have just gone away somewhere. And we've actually created it into a landscape feature that even when it doesn't rain and it's dry, it still looks very dynamic and it still looks very natural. It doesn't look man-made or you know, just very contrived. It looks very, very natural. And then this was the parking lot. And when we started on this project, and this is, you know, one of the things that I always talk about with parking lots is if you're going to try to do something in a parking lot, you better make the islands nice and wide if you have the real estate for it. So if you don't have to put in a pond or a basin and you can manage the stormwater in a large island, make it 35, 40 feet wide and make it into something that becomes a feature that people can walk through and interact with, but it's also a functioning system as part of an overall system to manage stormwater. It's just a different way of thinking about parking lots and you know, how we design them. And so, you know, this was the result. We created some bioswales and bioinfiltration. Again, the soil up here was really sandy. And what better client to have than a whole bunch of ecologists at a nature center to take care of the landscape. River Edge Nature Center was another project I was involved in where it was a one-story structure that was being proposed for indoor-outdoor classrooms and kind of blurring the lines between inside and outside. And at one point they wanted to talk about a green roof. And I'm like, you know, you're among thousands of acres of woods and natural area. You don't need a green roof. What we need to do is take this water off this roof where no one would see the green roof. Kids don't go up there. They don't even know it exists on a one-story structure. You're not looking down on it. Let's get that water off of the roof and create a dry stream bed that has bridges and rocks and plants and rain curtains so that when it is raining, kids can actually see it interact with the landscape. And it becomes much more of a creative way to create awareness of again, rainfall and how it interacts with the landscape instead of just trapping it up on the roof where no one was going to see it, appreciate it, or even know it existed. So again, these are fun things that you can do to just challenge the design team. So going back to that project or that photo I showed you of the Mecan River, if you look at the picture on the bottom right, there's a little bit of a problem here. When you look at the low flow channel and what I was talking about with trees being planted on the side slope, this was installed, I believe, in late summer. I did not design this project, but I photographed it a year later. That tree was dead. The salt and the amount of sheet flow going into this and sediment, and the fact that the tree was planted in the low flow channel defies what actually happens in nature. So again, this is not a good solution for handling runoff from a parking lot. I think there's better ways to do it. And even if you have a narrow island like this, there's other ways that you can do it. But it's really, really difficult to try to get something to happen in an 8-foot or a 9-foot parking lot island that, you know, sheet flows a bunch of toxic GAC into it and then wonder why trees and shrubs and other vegetation aren't thriving. It's just, in my opinion, the wrong place for green infrastructure. This won't work. The photo on the right, there's no backing on those curbs after one snowfall. The snowplows hit it, and all that curbing, not all of it, but a lot of it ended up down in the bottom of the basin. This is just not a good design solution for parking lots. I think if you took this real estate and the green space within that parking lot in those parking islands, and you pushed it out to the perimeter of the site, well, now you've actually collectively got a lot more green space and a lot more real estate to work with. And now you can do something a lot more effective than trying to plant butterfly weed in the middle of a quarry, like the picture on the left there. This was designed, this was permitted, this was built, and it didn't work. After 1 year, the plants are all dead, and that's because plants don't like growing in quarries. And a water coffin, I don't know what was the purpose of this, whether it was just stormwater, just trying to detain it, but obviously all the plants in there did not survive, because again, that is just not the place where plants want to grow. And that's why I called it a water coffin. But my colleague Nancy Wilson sent me this picture on the right, and I just loved it. She's like, this grass really wants to grow in this asphalt, so I called it grassphalt. But it's amazing when you start to see elements of nature trying to creep in and kind of take back what is left of the natural environment. So there's 3 types of configurations for stormwater basins, if you will. One is full infiltration that I was talking about, partial infiltration. Some soils will infiltrate some, but some of them are just a flow through. So there's no infiltration. The water just passes through these systems. It slows down, it traps sediment. The plants absorb that water, but it's not an infiltration type system. And then there's 3 types of geometry that we use, and that's the true basin. There's also planters and swales. That grass swale I was showing you out at Pabst Farms, that was a super wide swale, but it really manages water in a very effective way. And the other thing about these systems to consider is if you have enough space, is to try to avoid a single inflow into these systems. Don't try to cram as much water as you can into one pipe and throw it in here. You're going to have a lot of major erosion problems. So if you can dissipate that and spread it out and allow water to come in various areas slowly, you will mitigate, erosion problems and other scouring issues that you typically see on some of these systems. I know we all want to save money and we want to save pipe, and we don't want to cost our clients any more money. But if you want it to be successful, you have to start thinking differently about how to get water into these systems and then how to manage it. And there's a lot of
there's a quick question about, as you're going through all these, can you just talk about, are these your own design codes beyond the traditional stormwater designs that you see in most communities? There's just a question, where do you get these codes? If you're, the question's coming from a municipality north of Milwaukee, and I'm sure the community is looking at how would they incorporate the codes into their community.
That's a great point, and I was going to touch on that later, because municipal codes and ordinances when it comes to landscape are way behind the 8 ball on green infrastructure. It's starting to change, and I've met with many communities throughout the state to talk about how do you implement some of these things. We worked on a project with the City of Milwaukee Department of City Development on updating their landscape. We didn't change the code. The code is the code, and sometimes changing code, as you know, Carolyn, is like reversing the magnetic poles of the earth. It takes a lot of time and money and effort to change a code. But what you can do is you can augment it, and you can create, like we did for the City of Milwaukee, incentivize some green infrastructure on non-compliant sites and really start to look at your codes and ordinances from a landscape perspective. And I'll touch on that later, to try to incentivize, if you will, developers and property owners to implement some of these strategies. But you got to give them a carrot. You got to give them a reason to want to do it. And for those communities that have these codes and ordinances, and believe me, those are the bane of my existence, because we do work all over the US, and design by math when it comes to landscape is not a good design. It's just designed by math. It's check the box and, hey, we won, let's get approved. But is it really the best design? Probably not. It's just, you got to meet the code, and I understand why they're there, but I think we're woefully way behind on updating those. And I think we really need to rethink how those codes effectively are implemented on sites, not just for aesthetics. Everyone thinks more trees are better. I would argue that point. Diversity is good on plant material, but it doesn't necessarily mean loading up a site with trees is going to be the best thing. I call that cramscaping. And there are some communities around southeastern Wisconsin where I'm forced to do cramscaping. And so back to the question about the municipal codes, these are not my own codes. These are collective ideas that we have from the design team and the owner who wants to implement these strategies. And then how do we meet with the municipal staff and talk about this in a very, very interactive and collaborative way. So maybe not asking for a true variance, but can we implement this strategy versus that strategy? And I think there's a little bit of change going on in there, and it's going to need to continue to change.
I would say I see it more in a project specific case. Like
Sure.
they will have their own guidelines for their larger project, in addition to what you just described for the community. So,
yep,
okay.
I would agree with that. Yeah.
Okay.
And you see a lot of things happening in Europe where, they're using water plazas. So when it doesn't rain, these are urban plazas. When it does rain, they're water features. There's a book at the end I'll share with you that has some really, really creative ways to handle stormwater or rainwater in an urban environment. So how are we doing on time here? Are we at about 10 minutes?
Yep.
Some of the challenges and roadblocks to using native landscape for rainfall integration is fantasy land sometimes, where people say, I want it to look good all the time. I want low cost and I want low maintenance. And as I always say, there's maintenance and then there's higher maintenance, especially when you're talking about green infrastructure. But the low maintenance thing where you just throw down some native seed and walk away is just not gonna work. And that's why, I always say it doesn't have to be expensive, but it's not going to be cheap and easy. You really have to have a commitment from the owner and the design team and the facilities management people to really make these systems function and work and be effective long term. And I think that's one of the biggest challenges right now is just, the management of these systems, because there's just not a lot of people out there who fully understand it. And I also think one of the challenges is a lot of people don't like what I call messy scapes, or they think that native landscape always has to look like a bad hair day. I disagree with that. I think native landscape, if you're using switchgrass and rudbeckia and butterfly, and you're using it in a very creative way, it can be really, really aesthetically pleasing. It doesn't have to look like a box of crayons blew up in a bad hair day. So this is where I was talking about the municipal codes and mandated protocols are outdated. And I think that's what we really need to think about, is most native landscapes and green infrastructure do not meet current landscape codes. And that's a challenge. So, if you still have to meet the code, and then on top of that, you want to do green infrastructure, do you have the real estate to do that, and the willingness of the client and the owner to do that? And, a lot of times sites are designed by others. And then, as a landscape architect, we're left to what I call decorate the damage. This is not good integrated collaborative design. This is landscape as afterthought. And I don't think we're going to get the best results when we all work in our little compartments separate. And that's why I think the key to success is really, for GI, is it's integral and multidisciplinary. I call myself a site planner, but it's really a mix of all of these different disciplines in order to make something happen that we're all working together. So it's Carolyn, it's engineers, it's hydrologists, it's traffic engineers, circulation on a site. That's even a big part of it. The agencies, the contractor, and the client all have to kind of be working on the, sharing the same box of crayons in order for this to actually be successful. So I'll quickly go through some examples here. This was Sauk Prairie Memorial Hospital. It was 3 40-acre parcels out in Sauk County. It was all sand, and it was big sky country, all agricultural fields at that time. There was off-site flow coming from the west across Highway 12. It was a major waterway, not a waterway, but it was a major ditch that carried a lot of water. So we did not want to necessarily interrupt that. We had a lot of challenges to doing this site development. Across the street to the north was an airport. So if you've ever worked with the FAA, there are certain things that you can and cannot do in a flight path. And what you can't do is you can't have light poles, trees, cars, permanent structures, things like that. So we took that flight path and we said, what if we use that for our stormwater area? Because that was one of the allowable, and we use dry basins here. So in the flight path, we were able to use that as a plus rather than a minus. A lot of challenges, but a lot of opportunities to that site design. There's also gas mains and easements and all sorts of other things that we had, multi-jurisdictional approval process and all these other things that happened out there. But what was the really success of this project was that the facilities management people were at the table from day one. They weren't an afterthought. We didn't spring this upon them and say, okay, good luck. We had them at the table and we said, what capacity do you have? How much staffing do you have? What don't you want to do? And they didn't want to be mowing turf every day. So we came up with a short stature grass mix. And the reason I think that it was so successful is because we had the right contractors involved who were tied to the management. So who installed the landscape had to manage it for 2 years under a separate operator and maintenance budget, but also that I studied this pre-settlement vegetation in this part of the state. So 200 years ago, what was growing here? Well, I think if it was growing here 200 years ago, it'll probably do okay today. So that was kind of how we developed our seed mix and our plant regime in this area, is just by studying nature and what happened in the past. We also had a lot of sand, so we could infiltrate. So rather than hauling the sand off site and then bringing in a magic soil mix, some people call it engineered soil. That just makes me laugh. It's like calling things engineered sky or engineered, water. It's organic soil amendments, and we were able to use the sand on site because it met the technical standard to actually do the soil mixing on site for the infiltration basins. So we saved tens of thousands of dollars of trucking costs and hauling in order to use the sand. And so as a result, this was a photo I showed you before, but after one growing season, the photo on the top, that is the same basin. And its native vegetation is being managed by Agricol out of Illinois, and they are doing a great job at keeping the invasives out and letting this native vegetation do what it's supposed to do. Now that's a 3-year commitment or 2 or 3 year commitment. You can't just do this and walk away. You have to kind of stick with it. But also you can see in the parking lot islands, we made them much wider, and some of the things that you can do to kind of buffer parking and buffer cars that can be done in a very creative way. Lily Heights Park in Brookfield, this was a MMSD GIPP grant funded project. The bioinfiltration basins, nice wide median, nice wide parking lot island. We put in the organic soil amendments. We planted all the plant plugs, and the photo on the right was taken 2 years later. But what happened the first year is that it failed. And so live and learn, right? Why did it fail? Well, what we figured out is that our filter was too fine. We used perforated pipe with the sock. We used pea gravel. All the planets did not align on this one, and it ended up inundating, and what we thought killed all the plants, but it didn't kill the plants. Once we fixed the problem, we remedied the problem, we got it to drain properly, a lot of the native plants came back and we didn't have to replant anything. But this again was a lesson learned. We don't have this all figured out. It's not one and done. We're constantly learning. We're constantly challenged to try to do better on the next one. I'll go through this really quickly. Greendale, if you've been to the village of Greendale, this was a very large, robust project in the medians along Grange Avenue. Total project area was 50.94 acres. So what does that mean? It really traps a lot of water, removes 770 pounds of TSS annually. This was originally done with what I call a busy-scape, or like I was saying before, complicated and vague. And because of that, it made it very, very difficult to manage this project with village staff, because the village staff, they're not botanists, they're not horticulturists, they're summer help. And what happened is after they planted this and they went through all of this, so here's a picture, a year after it was planted. It looks pretty good. You got Joe Pyeweed in there. You got some other great, natives, but it became so weedy and it required so much maintenance. And the staff was just like, I don't know the difference between Joe Pyeweed and Queen Anne's lace and thistle. So it just turned into a big batch of weeds, and what they ended up doing is just mowing it like turf. The interesting thing about that, though, is when they cut it down and they mowed it like turf, it was still functioning, and water was still infiltrating through it. So it was still doing some good, but all the plants were basically gone. So we got brought in to redesign this, and what I did is I went big and bold. So at 35 miles an hour in a car looking out the window, you can actually appreciate this landscape because it's big and bold, and it really is a lot easier to maintain, because when you have a big glob of plants and they're all one type of plant, you can pretty easily identify what's a weed and what's not supposed to be there. So that was kind of the effect that we used, or the method that we used, to try to mitigate or reduce the maintenance for staff that isn't necessarily knowledgeable about plant material, is just keep it simple. Don't try to plant, one of everything. Use things in big, bold swaths, so that when they are in bloom, you can go through there and see what's not working, or what the problem is. There's a lot of stats here, and again, I don't want to bore you with this, but this is very valuable information because we were able to do a cost analysis on it, and that's always the big question: what's our cost per square foot? And then when you can start to apply that based on availability and labor rates and materials and cost of trucking and that type of thing, you can kind of synthesize it down to a square yard or a square foot cost. And you can use that as a quick estimator to, is this going to work for the client? Are they going to want to afford it? Is it within budget? If not, well then, maybe let's take a different approach to it. Real small sites, you can still do very, very creative things with native landscape and stormwater on small sites. This is on the corner of Leet and Holly Road. And just another way where we were able to implement different strategies in order to just slow down stormwater. The Madison Children's Museum rooftop garden, this is a really robust landscape because the structure allowed us to put in a lot of soil depth. So we were able to grow trees up there in a tamarack tunnel and do all sorts of whimsical things that you don't always get to do on a roof, but it's really, really a cool space. And if you haven't been there, it's worth a trip. Colectivo Coffee is another one where, again, the owners of Colectivo, at that time Altura, wanted to do something with their roof water. So aside from putting it in a cistern and using it as irrigation, we created a water feature that had a recirculating pump, and kids can kind of have these little rubber duckies float down these troughs. And when that surges, that goes into a dry stream bed, which then eventually makes its way slowly but surely to the storm sewer. So we've delayed the roof water from getting into the storm sewer as fast as possible. We've actually created a system in which it can be looked at and enjoyed. So moving forward, I think a lot of municipalities are leading the way, institutions, agencies, NGOs are leading the way, and it's creeping into the private development world, which is great to see. When I first started talking about this, it was not really being considered as a viable option to mitigate stormwater. So it'll happen, slowly but surely. Other parts of the U.S. are much more robust on this because they've been forced to be. And again, I think our spoiled Lake Michigan water that we're all spoiled about is something that is one reason that maybe that we're not quite as far ahead of the curve as other communities. And then some publications and books for reference. These are really cool books, the Artful Rainwater Design. And again, I can send these publications to Carolyn, and they can distribute them. Or again, I'd be willing to share this PowerPoint with anyone who's interested in it. A couple of really scary books, but good books. Again, this really kind of helped me understand our relationship with water and our water ethic, and what we're doing. I mean, when you realize that 39% of the people in Kewaunee County, Wisconsin, can't drink their water because of cow manure, yes, we have a problem. We have a problem here in the state, and we need to think about that differently. So anyway, there's a lot of documentary films out there. Kiss the Ground is one of them that just came out as well. And that is the end of the presentation.
Thank you so much. I think it's been really informative based on the dialogue that's been happening in the chat as well. One of the early questions about pavers was just sort of related to ADA accessibility and wheelchairs as pavers start to crack. But can you address some of the pavers and other GI in general in terms of ADA?
Well, there are some gravels and aggregates that are considered to be ADA compliant. And when you look through the ADA book, it says it needs to be firm, so you can not only just push a wheelchair on it, but people with mobility issues, even in just regular walking, are going to be able to navigate. The pavers are ADA compliant, and again, what the key to success there is making sure that they're installed properly. And as long as they're installed properly, they meet ADA compliance on vertical and horizontal tolerances. And then they've also developed some really cool pavers that have much smaller slits in them. So even for high heels and other things that kind of come up when you have these discussions, they're still performing really, really well. They're just kind of stretching out. Instead of having a large void space, they have a long, narrow, thin void space that's just as effective.
There was another question about just who to contact if you wanted to do it at a residential scale, and I believe there's some people posting about local contractors. Is that something that's difficult to find? Is it considered a specialty?
It's getting better. You know, in 2011, when I first started talking about it, there was just not a lot of landscape contractors that you could pick up the phone and talk to them about this, and they had staff that were capable and educated and knowledgeable about how to do this. But it's getting a lot better, and there are some very, very qualified contractors in this region that I always say if I had to start my career over, I would probably get into stormwater and GI maintenance, because the gene pool is pretty small. And I think it's something that's really, really needed in because to implement these systems, if you don't maintain them, you might as well be planting $20 bills.
There's a question also about how do you pick the correct engineered soil when you're talking about biodetention ponds. And one of my questions is also for you to just generally address the cost difference between a traditional stormwater pond and more like constructed wetlands or the naturalized one you talked about at Cabela's. Is that a big cost difference or close in payback?
It's a big cost difference. You know, it was the owner's choice. I think stormwater ponds are the most efficient way to trap sediment and settle sediment and get water quality as fast and rapidly as possible. But that doesn't always mean it's the best solution, because it eats up a lot of real estate. And in terms of the soils, you know, that's a real specific thing. And, you know, again, if you're working out in Oconomowoc, you know, there's a DNR technical standard on soils that infiltrate, you know, and they call it engineered soil. And there's a certain soil mix that's used. But again, I'll emphasize, you can't apply that to everywhere around the state. It's not one and done. You really have to understand the subsoils and what you're dealing with, and then how you want it to perform. Because if you are going to do this in heavy clay soils and you do want to get some infiltration, I'm not saying that clay soils don't infiltrate, they just infiltrate a lot slower. So now you're creating this sort of system that is holding water, acting as a sponge. The engineered soils are going to be very, very saturated because the water isn't draining out as fast as it would in sand. So therefore, your plant choices are going to be different, and your duration of water standing and your drawdown of that water is going to be different. So there isn't one, I guess, magic thing, but it's a good question, because every project we work on, we have to challenge ourselves with, you know, what's going to be the most effective, and you know, how are we going to get this to function so that it doesn't turn into a bad science project in 2 years.
Everything you've been talking about is connected to with the cost, right? And
Yeah.
Cost and then the long-term benefits. I guess coming back to the early questions about the ordinance and maybe the codes, are there like a top 3 things if a municipality says, you know, I really want to update our landscaping or a GI code? Are there some simple first steps communities could take to change their code?
I think so, and I've actually went and visited with several communities around the Milwaukee metro area, and it's not as if they're resistant to it, but yeah, there is some low-hanging fruit. And if you get a chance, I think we presented this at APA pre-COVID back in October of whatever it was, 2019. We came out with what started out as a brochure, then turned into a pamphlet, and is now a book for the city of Milwaukee, DCD. And we worked with Kyle Gast at the city of Milwaukee on that. And it's a simple handbook, and it graphically shows people how, not only landowners, but as well as people who are approving these plans, how can we implement some of these strategies in a very simple way without creating a big hurdle. And it was interesting, because when we gave that presentation, there was a lot of different people from a lot of different communities throughout Wisconsin and Minneapolis that were there, and we made these books available. and said, you can do this in your own community. So there is low-hanging fruit, and you don't have to completely rewrite all your codes and ordinances. But I will say, if you're one of the communities in Wisconsin that has the outdated 1974 landscape code, you probably should invest in updating it.
Mm-hmm. I'm posting the link because I'm very familiar with that report, and it's very good. I actually had a student just report on it this semester.
Oh, great.
It's very highly graphic, easy to use. It'd be good to actually document some of the successes as they go through that.
Mm-hmm. And that one photo I showed you of that non-conforming site, that tiny site on Vliet and Hawley, that was kind of a poster child of what that booklet really kind of brought together.
Okay. Are there any other, I know people are posting other resources, which is really great. I don't know if there's any other questions or comments if people want to unmute. We've had a great turnout. I know about 1 o'clock people start dropping off, but we've had a really good dialogue. I find it really informative because you're explaining it in a way that also that people can understand. The general public can understand the impact. It's not always just a technical aspect, but it's technical in terms of what's needed to move the needle. So yes, so Jenny's going to post a survey in the chat for those of you who are still here. We really appreciate your feedback. Tell us what you think, comments. Actually, Tom was looking for feedback, but we're also looking for ideas for future speakers. And I did want to highlight that our final Innovative Cities lecture for this semester will be December 7th. And it will be the Harbor District here in Milwaukee, and they're going to highlight the changes and the impact that we're having down there, talk about some measurements, and then what's to come. So that will be Tuesday, December 7th, online again. So again, thank you so much, Tom. We really